Now continuing on with the Year 8 revision on Pythagoras' theorem. Now starting with question 11, it says find f as a surd. Now surd means just keep your answer as a square with a square root sign, and that's an exact answer. So first of all, we should circle the hypotenuse, which is the longest side. Okay, so we've circled the side that we want to find, which is the f here, the longest side, which is the hypotenuse. Now that's also the side that we want to find. So remember, the longer side squared equals the sum of the two shorter sides squared. So we can write f squared equals 3 squared plus 6 squared. So the longer one, which is the hypotenuse squared, equals the two shorter sides squared. Now notice the 3 squared and the 6 squared are on the same side on your calculator, so you can just enter them straight into your calculator, or you can work them out individually. I'm just working them out individually here. 3 squared is 9 and 6 squared is 36. So if we add 9 and 36 on your calculator, you get 45. But what you could have done is just go 3 squared plus 6 squared on your calculator and jump straight down to the 45 there. So that's what f squared is. So therefore f is, to get that on its own, it's the square root of 45, because the opposite of squared is square root of 45. Now that way I'm leaving my answer as an exact answer, as a surd, and I haven't worked it out on the calculator. So you will only do that if it says leave your answer as an exact number. Now to question 12, we just start off by circling the longest side before we start. So our longest side is 13, which is the hypotenuse there. And so we know that the two shorter sides squared, so the p squared plus 7 squared equals 13 squared. Now because we're looking to find p, we should write that first. So always write the letter that you're finding first. So we're going to go p squared plus 7 squared equals 13 squared. Now, before we can work them out, because those 7 squared and the 13 squared are on different sides, we should work out what they both are on the calculator. So we know that 7 squared is 49 when you do it on the calculator, and 13 squared is 169. Now we need to get the p squared on its own, so the plus 49 needs to go over to the other side, and it'll become minus 169. Sorry, I've just got a little mistake there. So p squared is 169 minus 49. You can work out 169 minus 49 on your calculator, and you will get 120. So that's what p squared is. And remember, p, you have to do the square root of 120, because the opposite of squared is square root. So p is the square root of 120. Now we can stop the question there, because they want us to leave the answer as a surd, which is the exact answer. Once you start putting that exact answer into your calculator, you'll end up with an answer that's not exact, that's been rounded. But remember, only do that if they say leave it as an exact answer. Now for question 13, it says, which one of these is a Pythagorean triad? Is it the numbers 8, 15 and 17, or is it the numbers 6, 10 and 16? Now, a Pythagorean triad is a set of 3 numbers where the longest side squared is equal to the two shorter sides squared. So if we look at the numbers 8, 15 and 17, then 8 and 15 are the lengths of the two shorter sides, and 17 would be the length of the longer side. So what we need to do is work out the two shorter sides and square them and add them together and see what we get. So we'll start off with the two shorter sides. So we go 8 squared plus 15 squared. We just do that on our calculator and we get 289. Then we can look at the longer side, which is 17. So we can do 17 squared. That's also 289. So because the two shorter sides, when I square them and add them together, I get 289. When I square the longer one, I also get 289. That means that Pythagoras' theorem works, that the two shorter sides squared add up to the longer side squared. So because these two numbers, the 289s, are equal, we can say that the numbers 8, 15 and 17 are a Pythagorean triad. Okay, now we're going to do it with these 3 numbers over here, 6, 10 and 16. So we'll look at the 2 smaller numbers, that they would be the 2 shorter sides in the triangle, and we'll square those and add them together. So we get 6 squared plus 10 squared, and we work that out and we get 136. So that's the two shorter sides squared. Add them together, we get 136. Now let's look at the longest side squared. So the longest side is 16. So we do 16 squared and we get 256. Now these two numbers, 136 and 256, are not the same. So we say these are not equal. So therefore this is not a right angle, like it's not a right angled triangle. So this is not a Pythagorean triad. It'll only be a Pythagorean triad if the two shorter sides squared, when you get your answer, if it adds up to the longest side squared. Now in question 14, where we have to test whether this triangle is right angled, the same rule applies as for the Pythagorean triad. We look at the two shorter sides and we square them and we add them together, and they should equal the longer side squared, because that's Pythagoras's theorem, and Pythagoras' theorem always works for right angled triangles. So we're going to start off looking at the two shorter sides squared. So we're going to go 10 squared plus 15 squared, and we work that out and we on our calculator and we get 325. Then I'm going to look at the longest side, which is the hypotenuse, and we want to square it. So 20 squared is 400. Now those two numbers, 325 and 400, are not equal, so we say these are not equal. So we can now say, well, so the sum of the two shorter sides does not equal the longest side squared, so it's not a right angled triangle. So we're basically doing the same as what we were doing up here in question 13. Same reasoning, the same method as for working out if it's a Pythagorean triad or not. Now we're just going to do the same thing again here for question 14b. First you have to see which one's your longest side, that's 17. So we want to see whether the two shorter sides squared add up to give the same answer as the longest side squared. So we're going to look at the two shorter sides, which are 8 and 15. We want to square those. So the two shorter sides squared are 8 squared plus 15 squared, and if you do that on your calculator you get 289. Then we can look at the longest side squared, which is the hypotenuse. So 17 squared is also 289, so these this time are equal. So therefore that means that the sum of the two shorter sides squared equals the longest side squared. So we can say that the sum of the two shorter sides squared equals the longest side squared, and so therefore it is a right angled triangle. Okay, and that's the end of question 14. Okay, now we're going to use Pythagoras' theorem to look at some worded problems. And this is question 15 in your booklet. Now we're told this is a TV screen and it's 41 centimetres long and 31 centimetres high. And we have to find the length of the diagonal. Now the diagonal goes from one corner here over there to the opposite corner there. So if we look at that, we actually have a right angled triangle, and the right angle is down there, so I'll just draw that in. So the reason we know it's a right angle is because we've got a rectangle here. Okay, so we're going to start off saying we need to find the diagonal, so I'm going to put a little letter D there as well. So I've got my right angled triangle. D is my hypotenuse, it's my longest side, so you should put a circle around that. And so we say D squared equals 31 squared plus 41 squared. So the longest side squared, which is the hypotenuse, equals the two shorter sides squared. So I'll just write that in over here. So D squared equals 31 squared plus 41 squared. Now the two numbers here are on the same side, so into your calculator you can just do 31 squared plus 41 squared. You can do that straight away, or you can work out each one individually. You can say 31 squared is 961, 41 squared is 1681, and you can add them up. You get F squared is 2642. Sorry, I mean D, not F, okay? So then we want to work out D on its own. Now, opposite of squared is square root. So we can now say that D is the square root of 2642. We can work that out on our calculator. and we get 51.4. Now we have to look at all these answers and they're to the nearest whole number. So we look at this 0.4 and that 4 is less than 5. So we keep that 51 the same. That 1 there stays the same. So we can say, well, that's closer to 51 centimetres. It's not closer to 52 centimetres because it needs to be 51.5 centimetres or more to be closer to 52 centimetres. So our answer is that D is 51 centimetres. Now for question 16. You have to look at the question. Let's read it first. So we have a flagpole of height 5 meters. So girls, this is the flagpole. It stands straight up from the ground. It stands straight upwards and it's 5 meters high and it's tied to the ground by a 7-meter cable. So this is the cable. Remember, a cable is just like a really strong rope. Okay, so there's our cable holding the top of the flagpole. Okay, and the question is, how far from the base of the flagpole? Now here's the flagpole. The base of the flagpole is the bottom of the flagpole. So how far from the base of the flagpole is the cable tied? So this cable here is tied to the ground. We need to know what this length here is. Now I'm just going to call that D for distance. Okay, and you can see that we've got a right angled triangle and our longest side is 7. So I'm going to circle that. So our longest side is circled. Now, because we're trying to find D, we should write that first. So we say D squared plus 5 squared equals 7 squared. So the two shorter sides squared, D squared plus 5 squared equals the longest side squared. So we've got D squared plus 5 squared is 7 squared. We should work out our 5 squared and 7 squared first. So we get D squared plus 5 squared is 25, sorry. And 7 squared is 49. Remember, we're trying to get D squared on its own, so we're going to move this plus 25 over to the other side, and we'll get D squared is 49, take away 25. Now that the two numbers are over here together, we can work that out on the calculator, and we get 49 minus 25 is 24. Now that's what D squared is. It's not what D is. So to work out D, we have to do the square root of 24. Now you can do that on your calculator. You get that the square root of 24 is 4.8989. So we need to round to 2 decimal places because all these answers, except for that one up there, have 2 decimal places. So we want 4.89. We have to decide, does that stay a 9 or does it go up? What we need to do, we need to look at the number after the 9, which is the 3rd decimal place, which is this 8. Now this 8 is bigger than 5, so it's 5 or more. So this 9 needs to move up to a 10. What you really need to do, if you read it as 4.89, that needs to go up by 1, so you can write it as 4.90. Okay, so our answer is 4.90. That's the end of this video. The next video will start from question 17.